So modeling lesson number 5, Autodesk.com, Products, Fusion 360, Learning Training Tutorials. It's working with holes, threads, and the shell command. 12 slide deck. We're going to come over to the data panel, basic training, modeling, threaded mount. That's what we have to start with. So that's what the first few slides are. So then what we're going to use now is the hole feature. So to do that, we're going to expand our sketches and turn on our hole feature sketch. It's smart because what they've done is just created a sketch that we can click on the 4 points in order to put holes in the right place. Then the next thing we're going to do is enable the hole command to create 4 counterbored holes. Create hole and click on all 4 corners. 1, 2, 3, 4. And we've got a bit of dimensions to add in. So we're going to go counterbore, selected all 4. Depth is going to be all 7.5, 118, 2.5, and 10. So we've got counterboard already selected, simple, counterboard. Simple is the default. In this case, we're using a counterboard. And all the way through is what we're looking for. So let's go back and check out our dimensions. We want the diameter to be 7.5. This should be all. Counterboard depth to 2.5 mil. Counterboard depth 2.5 mil. Tip angle 118. Counterboard diameter 10 millimeters. Yep. Next slide, and it'll say make sure the hole command is going in the correct direction. Right now you can see that I am able to click on it. If the direction was reversed, you wouldn't be able to click OK, and that would be the problem. Now you can see the red showing through. That's what's allowing you to cut. OK. If we look from the back side, we've got our counterbores, recessed pocket. Next slide. Set the inside thickness to 2.5 millimeters in the direction. So I went too fast. So enable the shell command and click on this face. We're going to modify shell. Click on this face. When selected, this isn't chosen as a default. But for this exercise, choose the tangent chain. Make sure the hole command. Enable the shell model. Flat face. Set the inside diameter to 2.5 millimeters. So here where it's at 0, we're going to go 2.5. You see the whole center of it get hollowed out. It's awesome. Click OK. Next over is to expand the timeline bar to reveal more of the component. So down here you can see that the timeline bar isn't even all the way to its furthest extent. So now I've extended the line over so you can see all of the features. What showed up that wasn't there was this boss as well as another sketch. Turn the sketch web feature, enable the web command to create supports on the inside. So we go back up to our sketches, we can see our web feature. And just click so we're looking straight on. And create web. And click on the first line, then hold Control, click on the other 3. We want to go symmetric. We want to go to 2 next, thickness of 0.25. And if I hit the flip direction, you can see it won't let me click OK because it's going the wrong way. And if you rotate a bit, you can see the webs that have been created as a result of that line. Next, click OK to complete the command. Apply a chamfer to the end of the shaft, 3 millimeters, and it's equal distance. So we go modify, chamfer, rotate this, select the edge, and equal distance and 3 millimeters. Click OK. Next slide. Use the thread command to create threading on the shaft. Activate the thread command and select the outer face of the shaft for the thread to be applied. So we're going to go to create thread. Click on the face. So we've clicked on the face. I'll just rotate the cube a bit so you can see. And I've got modeled and full length snapped. If you take model off, it just gives you an outline of it, but it actually changes the physical model if you click that box. So we're going to leave it as an ISO metric thread, a size of 39 millimeters, a designation of M39 by 4, so that would mean that it's a 39 millimeter diameter, and it's 4 millimeters pitch, so from the top of one thread pitch to the next is 4 mil. Classification is 6G, and it's a right-hand thread. There's a screenshot of what you're looking at. And next we have to go and set physical material, navigate to metal in the folder, and choose steel alloy. So we're going to go click OK. Threaded mount up at the top, right click. We're going to go to physical properties. Decollapse plastic from our last one, and we're going to look for steel alloy. Tons of different aluminums, iron, platinum, stainless steel. And maybe the first steel that I just saw there. Look. Steel alloy. There we go. Pick it over to the part. And we have a steel alloy piece. Do that one more time just to make sure. Okay. Close. And we should end up with a size of 1412 grams if everything is being modeled correctly. So when you go into properties, there we go, you can see your mass. 1400 grams. Alright, have a go at this, try it out. Let me know if you have any questions, either in the comments or via email.